came, I come to this proposal that I'm going to show you guys. This is about the design and implementation of a Wi-Fi controlled automatic sliding gate system with an Android integration and infrared sensors. This is the slowest I can do. Alright, let's move on to firstly, it's about the background of study. Well, personally, I think safety or things that are a hassle about like gates and stuff, or like housing, for example, like things like water or what's it called, like last night, like rain happened and like the roof like fell and there's water that came in. That's a hassle. But one main thing that is a hassle for me is manually opening the gate. This is very inconvenient. Well, in bad weathers such as night, and also for the elderly, where they have not as much strength as us youngsters. Next, I thought of the automation system, which is the IoT, and the mobile controller, which gives us a new opportunity for automation. And I made it so it could be very affordable, efficient, and very smart for homes. Next, the problem statement. Well, it's basically what I said earlier. There's traditional gates lack safety and conveniences. Commercial auto gates are expensive and non-customizable. Whereas mine, it's a two-piece. One is the motor that you can buy, and there's going to be the gear, and there's going to be the rack and pinion, which will be stuck all together, and it could be stuck onto your personal houses. Next, many systems lack key features such as mobile integrations and sensor feedback, which we will get onto within the presentation. Next, my objectives: design a stepper motor gate using a rack and pinion, calculate the required torque, develop Wi-Fi control via Android application, and integrate PIR sensors plus LCD feedbacks, and fabricate and test the full prototype. This is the scope of the study. For the mechanical part, it is the track, the motor, the rack and pinion, and for the electronics, this is the Arduino Uno, node MCUs, and sensor LCDs. And the software that I'm going to be using for the application is Blink plus MQTT and communication. Next, there's the literature review. IoT improves gate automation has been one, and we also showed that Node MCU and Blink simplify mobile control. And stepper motors ensure precision, which we'll get on to later on. And PR sensors improve safety, and fireworks, RFID, smart lighting, servo-based systems. Next, these are the previous researchers where I got my ideas from. The Jalani, which is for the Arduino, and Padini, which is the Node MCU plus the application, and Adlie is for the RFID plus the buzzer alerts with the motor control. Next, the system design. Well, in my design, there's going to be the Arduino and the MCU, the Node MCU, which handles the control and the Wi-Fi, PR sensors to detect the gate position, and the LCD, which gives us real-time feedback, and an Android app sends via the Wi-Fi. And it could only be viable with the Android, and soon it could be maybe moved on to other Android. Next, this is the design for the support system, I would say. Android app, and it moves on to the Node MCU. The Android app sends a signal to the Node MCU, which then moves on to the Arduino, which gives the signal next to the stepper motor. Sorry, there should be a power inlet for the stepper motor. And there's going to be the PIR sensors, which detects the gate position, and the LCD shows us the state of the gate. Next, this is the mechanical design. For the mechanical design, like I said before, it has the rack, the pinion, and the stepper motor. And to create a perfect rack and pinion, we have to actually calculate the torque and the bending force. The bending force actually shows the torque helps us choose the right stepper motor, and the bending force helps us create the perfect rack and pinion. Why do we calculate the bending force? It is so that the stepper motor won't exceed or have enough power to actually spin the gear, the shaft onto the rack. And the bending stress is actually momentum times the axis between the gates and times the inertia, which helps us create the perfect sliding gate. And to choose the correct material and the right weight, so the gate won't break in half. Next, this is the mechanical design that I have done, but this is not 100% proof yet, since I have not tested it yet. And this is how this is an example of how it would look like. Where this is the motor, this is the gear, and this is the vacuum cylinder, and you can see the other things that I will create these ones. Right. Next. Right. This is the future work and the expected outcomes that I will want. Functional smart gauge systems with mobile controls, real-time status feedbacks on the LCD, smooth gauge movements using stepper motor, scalable for house applications, and future upgrades. Hopefully with auto lock, maybe camera, solar, and one more thing that I forgot to mention is voice control. This is the planning testing procedures. The first thing that would, to create a perfect sliding gate, I will have to test the Wi-Fi responses and evaluate the motor performances under gate load, and check the PR sensor's accuracy for open and close detection. And the PR sensors would actually give feedback to the LCD and system stability, analyze power usage and range of control. And this is the conclusion of everything. Affordable smart gates using IoT, mobile app and sensors, reliable movements and user-friendly control, scalable for house users, future upgrade solars, and overall camera integrations, hopefully. And also voice control. And that is all for my presentation. I hope you guys like my presentation, and I am now open to questions from you guys. Thank you.
Okay, thank you for